Hey guys, what it do? It's your boy Carson White. I'm in Tuesday's lab. I really don't know when this is due. You're probably wondering why I'm in a cutoff. I just got done working out. I got a sick pump. I'm freaking huge. I dressed up a little bit. Hope that's extra credit points. Anyways, let's get going. So my project is coronavirus and how that is involved with the Kim mystery. I started it off with a very formal paragraph. I said our world has recently been fighting each and every day to seize a global pandemic, corona. Business, workers, schools, etc. have been affected by this modern day plague. This virus is very deadly to some, this, that, and the other. And so I basically have broken it down to how scientists and chemists and all them work together, and how they understand the structure and form of how it's made, to see if they can either get inside of it, or how they can just attack the virus or understand it better to slow it down. Smart people things. I started it off with the structure of the novel COVID-19 virus reminds me of a Lewis structure. Big brain. It reminds me of a Lewis structure compound of an element. And I said, just like how students need to understand the Lewis structure of an element to see how, an element or anything, can function, chemists and scientists also need to understand the structure of the virus to know how to fight it and see how it moves, how it interacts with other things. So chemists and scientists are the ones who discovered that COVID-19 is actually a spiked protein. My pants are wet. I don't know why. And which made them better understand why the disease is such a big deal, because the spiked protein means that it plays a key role in the receptor recognition and cell membrane fusion process. So it basically just means it's just harder to penetrate and harder to maintain, and that's why it's such a big deal. So thank you, chemists, for doing what you do. Honestly, you guys are slept on. Professor Abby, slept on. Remember, you're the GOAT. So, an article actually at done at the U of I was done. It's called "Chemistry Researchers Fighting COVID-19 on Several Fronts." So it better explains in detail how chemists are the ones who are doing actually a lot to understand and fight this virus. It basically just says how they develop more accurate, widely deployable testing methods to better detect COVID and to just stop the virus, and future coronavirus pathogens altogether. The summary basically was just, how everyone's doing their part and how chemists help other people do their part, because chemists give and supply answers to other, scientists and whatever they want, and everyone works together, and it's so good. So, in chemistry, in another article is Chemistry and Coronavirus Research, a free-to-read collection from the American Chemical Society. The author, Michael Sokolova, states several keynotes on how chemistry plans, chemists basically plan to intervene with the virus. Here's a quote actually from the author, who says, "Chemistry has a key role to play in understanding everything from viral structure to pathogenesis, the isolation of vaccines and therapies and all that other, like I said, smart people stuff." And I said, just like how students run tests in, chemistry labs that we do every Tuesday that I'm literally so good at, chemists run tests like that, but for corona. So, we do it with what's it called? Salt and water. You mix those together. There's a certain word for it. I'm just, I'm not there right now. So, but they do that, with COVID, and they're doing it with more serious items and stuff like that. And so in the article, Persistence of SARS-CoV in Water and Wastewater, multiple scientists in this study set up a lab to detect SARS in feces of infected individuals to see if temps of 20 degrees Celsius to 50 degrees Celsius and 70 degrees Celsius, to see if temp can either kill the virus or just reduce it. And they gathered actually that, quote, the times for 90% reduction of SARS in wastewater and tap water at room temp was like 1.5 to 1.7 days. Like, that's how long it takes for the virus to die in that the degrees. So in chemistry, labs are done to prove a hypothesis of a certain experiment, but many chemists have run their fair share of labs to get possible hypothesis for this virus. So they've done their part, they supply their information, boom, domino effect. Corona, no chance against chemists. Ain't that right? Love chemistry to a certain extent. So when their studies have found that the structure and function, like once they understand the structure and function from their tests, these tests were easier to set up, to run and try, because those tests just kind of narrow it down. So then once they find, basically the root, which is what they're doing now, then boom. 1, 2, fight the virus, and we have it. So, I mean, basically that's I was just basically trying to, involve just how we do Lewis structure and how we need to understand Lewis structure to understand an element, and how Lewis structure basically is kind of on the same path as how chemists, what they do to understand structure and function of COVID, and how their tests and that they run their hypothesis is the same thing that we do when we go in there every Tuesday at 7 a.m. in the morning. That we do that though, and I'm just saying it's the same thing. So this was fun. I had a great time. I hope you guys watch this and you enjoy the bow tie. And my room, I set up Christmas lights. Bye. Oh.